Hi guys, welcome to our class on circle theorems. Now before you can understand solution of this question, you must have been able to understand the theorems, the various theorems in circle, and you must have gone through the previous videos. And now let us look at how to solve this circle geometry problem from GCSE examination past paper. Now we have the circle as shown, and we are given that the circle is not drawn to scale. Okay, let us look at the instruction. Okay, a brief look at the instruction. A few minutes, I'll take it back to the diagram. S and T are points on the circumference of the circle center O. PT is a tangent to the circle. SOP is a straight line. Angle OPT equals to 32 degrees. Write out the size of the angle marked X. Give reasons for your answer. So let's take it back to the diagram. Okay, the instruction says we have S and T to be points on the circumference of the circle. Okay, let's show that. Now we have S and T. There are basically 2 points on the circumference of the circle. As you can see, points S and T are touching the body of the circle. SOP is a straight line. Okay, we have SOP to be a straight line. Look at that. Okay, that's the straight line SOP. Angle OPT equals to 32 degrees. Let's locate that. Angle OPT, angle between the line OP and the line PT at the middle at P. Okay, that angle is 32 degrees given according to the examiner. And we are required to find the size of the angle marked X. So we want to find the angle marked X. So those are the informations given in the question. And don't forget that we are told that O is the center of the circle. Very important. Now, how do we get the size of the angle marked X? A lot of theorems will be popping into my head, and I can easily see that OT is radius of a circle. The radius of a circle is the distance from the center of the circle to any point on the circumference. Now we see that OT is the radius of the circle. Now remember that one of the theorems in circle is that a radius of a circle is usually perpendicular to the tangent of the circle. The tangent of the circle is a straight line that touches the circle externally at only one point. Look at the tangent. This is the tangent. PT is the tangent, alright? So OT is radius. So if OT equals to radius, and we know that radius of a circle is perpendicular to the tangent of the circle, the word perpendicular means radius makes angle 90 degrees with tangent. So here I have angle 90 degrees at this point. Now remember, I have triangle OPT. Triangle OPT. And don't forget that the sum of angles in a triangle is 180 degrees. Now the angle POT can be easily obtained. So let us obtain angle POT. We have angle POT, measure of angle POT plus 90 degrees plus 32 degrees equals to 180 degrees. Sum of angles in a triangle is 180 degrees. So let us sum up 90 plus 32. 90 plus 32 equals to 122 degrees. So measure of angle POT plus 122 equals to 180 degrees. So measure of angle POT equals to 180 minus 122 degrees. Okay, measure of angle POT is 58 degrees. Okay, now let's fix that into the diagram. Now here we have 58 degrees. Remember that we are told that SOP is a straight line. SOP is a straight line, okay? So here we have straight line SOP. And don't forget the theorem that sum of angles in a straight line is 180 degrees. So if sum of angles in a straight line is 180 degrees, the remaining angle here will definitely be 180 minus 58, and that's equals to 122 degrees. Okay, so that's 122 degrees. Anyway, that can be seen as exterior angle of a triangle equals to sum of two opposite interior angles. Okay, let's just use 122 degrees as angle SOT. Now we are required to find angle X. Remember that the radius of a circle is the distance from the center of the circle to any point on the circumference. So if OT equals to radius, in the same way OS will also be equals to radius. Definitely OS will also be radius. So those two lengths are the same. Distance from center to circumference OS, distance from center to circumference OT. Now this implies that triangle OST is isosceles. Now why do we call triangle OST isosceles? When two lengths of a triangle are the same, it's definitely an isosceles triangle. So if two lengths are the same, that means that those two lengths that are the same, which is OS and OT, OS and OT are the same, will be resting on the base. Then the base will be ST. Look at the base of the isosceles triangle. One basic important theorem about isosceles triangle is that base angles are equal. Base angles are equal for isosceles triangle. So we said OS and OT are of equal length resting on the base ST. So the base angle lying on ST will be the same. So if here is X, definitely here too will be X. Now we can use the concept that sum of angles in a triangle is 180 degrees. Now what triangles are we going to be considering? We'll be considering triangle OST. Let us sum up the angles in triangle OST to give us 180 degrees. So we have angle X plus 122 degrees equals to 180 degrees. Now x plus x is 2x. So 2x equals to 180 minus 122 degrees. And that's equals to 58 degrees. We divide both sides by 2 to find the value of x. So x is 58 divided by 2 and x equals to 29 degrees. So final answer to our question, x equals to 29 degrees. Now you see the way I've been able to use some of the theorems in circle geometry to obtain my final answer. First, I use the fact that a tangent to a circle is perpendicular to the radius of the circle, makes angle 90 degrees with the radius. I was able to use sum of angles in a triangle to be 180. I made use of sum of angles in a straight line also to be 180. And I was able to understand that OS and OT represent the radius of the triangle OST. OS and OT represent two equal sides of triangle OST, since OS and OT are radii from the given circle. Thank you for listening. I'll see you in subsequent question. Thank you.